This is the video for Unit 7, moles. By the end of this unit, you will be able to use dimensional analysis to make conversions, define and use the concept of a mole, convert between the number of particles, moles, and mass using dimensional analysis, use moles to calculate the number of atoms, ions, and molecules in a sample of material, and calculate percent composition, empirical and molecular formulas. What is dimensional analysis? Dimensional analysis is the process of solving stoichiometric and other types of problems by including and canceling units for all quantities. Why is dimensional analysis important? Units are constantly needing to be converted throughout chemistry. And you'll really use this. Have you ever found a recipe that was in metric units? Or maybe you wanted to make more than a batch of cookies. How do you use dimensional analysis? This is done by using conversion factors. You can multiply anything by 1 without changing the meaning. What's a conversion factor? A conversion factor is any ratio of numbers and units that equal 1. For example, 12 to 1 equals 1 when the 12 represents the number of inches in 1 foot. Step 1. Write down what you know. Then write down the units that you have. Then write a multiplication symbol. Leave a space for the units that you want, or draw a line. Fill in with the conversion factor to cancel the units that you don't want. So the units that we have, to cancel, you have to have 1 on the top and 1 on the bottom. Then check your units before you do the math. Inches cancel, and we're left with feet. Finally, do the math. Multiply everything that's at the top, and then divide by everything that is at the bottom. So we have 24 times 1 divided by 12 equals 2 feet. Then check your significant figures. So our answer needs 2 significant figures. Finally, ask yourself, is this answer reasonable? Let's try it. The first one, how many days are in 57 weeks? So we start with writing our conversion factor. 1 week equals 7 days. What we started with, or what we were given in the question, goes in our first box. So 57 weeks. Then we're going to use our conversion factor. So 7 days is the unit that we want. It goes at the top. 1 week would go at the bottom. So our weeks can cancel out. The unit that we're left with is days. So this is set up the correct way. So we would multiply, and we have 399 days. Number 2, ask for how many hours are in 75,496 seconds. So we know that 1 minute is 60 seconds, and 1 hour is 60 minutes. So those are the 2 conversion factors that we're going to use to solve this problem. So first we write what we're given in our problem and draw our line. Since we have seconds, we need to use this conversion factor first. So seconds needs to be at the bottom, and minutes, which is the unit that we want, goes at the top. Our seconds cancel out, we're left with minutes. So now we'll use the second conversion factor. This time minutes goes at the bottom, and hours goes at the top. So our minutes cancel out. The unit that we're left with is hours, and that's what we're wanting. So we have 209.71 hours. Number 3, 8.2 gallons equals how many quarts? So 1 gallon is equal to 4 quarts. So we start with what we're given, 8.2 gallons, and we're going to use our conversion factor. So the gallons go at the bottom, the quarts are the unit that we want, so they go at the top, and we get 32.8 quarts. Okay, the next one. How many kilograms are in 56 pounds? So our conversion factor is 1 kilogram is equal to 2.20426 pounds. we draw our line. We have 56 pounds. So the pounds have to go at the bottom, and the 1 kilogram goes at the top. So when we divide 56 by 2.2, we get 25.4 kilograms. Okay, and the last one, we have miles to yards. So 1 mile is equal to 760 yards. So pause the video and try to answer this one on your own. Moles. The mole, abbreviated MOL, is a counting unit used by chemists. 1 mole of any substance is equal to 6.02 times 10 to the 23rd particles. A mole is equal to Avogadro's number, which is 6.022140857 times 10 to the 23rd particles. So where did that number come from? The mole is based on the number of carbon-12 atoms found in exactly 12 grams of pure carbon-12. So you're probably more familiar with some other counting units like dozen, bushel, or ream. What is molar mass? The atomic masses on the periodic table are the molar masses of the elements in grams. The molar mass of each element is different because 6.022 times 10 to the 23rd atoms of carbon wouldn't weigh the same as 6.022 times 10 to the 23rd atoms of nickel. This is also true for compounds. A mole of water would not weigh the same as a mole of carbon dioxide. How do you find the molar mass? To find the molar mass of an atom, use the mass that's given on the periodic table. Ions have the same mass as neutral atoms since the gain or loss of electrons has little effect on the mass. So look at a periodic table. What is the mass of 1 mole of strontium? So 87.62 grams. And what is the mass of 1 mole of argon? 39.95 grams. What is formula mass? Formula mass is the mass of compounds. This is very important when determining the amount of products that should be formed by a reaction. How do you find the formula mass? First, find the mass of each element in the compound. Step 2, multiply the mass by the subscript for that element. Step 3, add the masses of each element together. What is the mass of 1 mole of zinc oxide? So we find the molar mass of zinc. 1 mole of zinc is 63.55 grams. 1 mole of oxygen is 16.00 grams. Multiply by the subscripts. In this case, they're both 1, and then we'll add them together. So 1 mole of zinc oxide is 79.55 grams. What is the mass of 1 mole of CO2? So first we need to find the mass of carbon, which is 12.011, and then the mass of oxygen. Then we're going to multiply by the subscript. So carbon's subscript is 1, oxygen's is 2, and then we add them together. So 44.011 grams for 1 mole of CO2. What is the mass of 1 mole of lithium phosphate? So we need the mass of lithium, which is 6.94, the mass of phosphorus, 30.97 grams, and the mass of oxygen, 16. Then we multiply by the subscripts, and then we add everything together. Okay, try the last one on your own. What's the mass of 1 mole of sodium acetate? Mole conversions. You can convert between moles in different units. This will allow you to calculate products in different reactions. Moles to mass is the one you will use most often. To convert between mass and moles, you need to use the formula mass. So how many moles are in 16 grams of water? So first we need the formula mass of water. Now we're going to set up the problem using dimensional analysis. So we have 16 grams of water, and this will be our conversion factor. 1 mole of water is equal to 18.016 grams of H2O. So our 1 mole goes at the top because that's what we're looking for, and our 18 grams of water goes at the bottom. So we multiply by what's at the top, divide by what's at the bottom. So we get 0.8881 moles of water. The next type of conversion is moles to volume. So to convert between moles and volume is very important when looking at reactions that have gases. To convert between moles and volumes at STP, STP is standard temperature and pressure, you'll use 22.4 liters per mole of gas. How many moles are in 3.25 liters of argon at STP? So you start with your 3.25 liters, write out your conversion factor. So 1 mole of argon is 22.4 liters. So if we have 3.25 liters of argon, our mole goes at the top. That's what we want. The 22.4 liters goes at the bottom. So we have 3.25 divided by 22.4, and that should give us 0.145 moles of argon. And the last type of conversion is moles to particles. So to convert between moles and particles, use Avogadro's number, 6.022 times 10 to the 23rd. How many atoms are in 6 moles of francium? So 1 mole of francium is equal to 6.022 times 10 to the 23rd atoms of francium. So we start with what we're given, 6 moles of francium. This time, since moles is at the top, our 1 mole needs to be at the bottom. And 6.022 times 10 to the 23rd atoms goes at the top. So we have 3.61 times 10 to the 24th atoms of francium. So when you're converting between moles and mass, you're going to use formula mass. Whenever you're converting between moles and volume, you'll use 22.4 liters. And when you convert between moles and particles, you'll use Avogadro's number, 6.022 times 10 to the 23rd. Mass to mole conversions. How many moles are in 6.456 grams of potassium permanganate? The first thing is to find out the mass of KMnO4. So 1 mole of KMnO4 is equal to 158.04 grams. Then we set up our problem using dimensional analysis. 6.456 grams. What we want goes at the top, so we're looking for moles. So the 1 mole from our conversion factor goes at the top. The 158.04 grams goes at the bottom, so our grams cancel out, and we have moles KMnO4. So we get 0.04085 grams. How many grams are in 0.023 moles of sodium bicarbonate? Well, the first step is to find our mass of sodium bicarbonate. So 1 mole of baking soda is equal to 84.009 grams. So what we're given always goes in our first square. Then we use our conversion factor. So what we want goes at the top, 84.009 grams over the 1 mole. And when we multiply, we get 1.93 grams of sodium bicarbonate. When we look at our significant figures, we need 2. So our answer should be 1.9 grams NaHCO3. Next problem, find the mass of 4.5 moles of aluminum. So we start with writing our conversion factor. 1 mole of aluminum is 26.98 grams. So we have 4.5 moles. Our moles need to go at the bottom of the problem, or in the bottom box. The grams go at the top box. When we multiply, we get 121.41 grams. We need 3 significant figures, so 121 grams of aluminum. And our last mass to moles conversion. What is the mass of 3.00 moles of HBr? So we need to find the mass of HBr. 1 mole of HBr is 80.0 908 grams. We're starting with 3 moles. What we want goes at the top. So we're wanting grams. We have 1 mole. So the moles of HBr cancel out. And we get 242.7 grams. We need 3 significant figures. So we're going to round the 2. So 243 grams of HBr. Mole to particle conversions. How many atoms of aluminum are in 4.5 moles of aluminum? So the first thing we need to know is how many atoms are in 1 mole of aluminum. So 1 mole of anything contains 6.022 times 10 to the 23rd atoms, particles, or molecules, depending on what you're looking at. So then we put what we have in our first box, 4.50 moles of aluminum. What we're wanting to get to goes at the top box, so that would be the 6.022 times 10 to the 23rd atoms. The 1 mole goes at the bottom. So our moles of aluminum cancel out. When we multiply, we get 2.71 times 10 to the 24th power atoms of aluminum. The next one is how many atoms of hydrogen are in 3 moles of HBr. So if we have 1 mole of HBr, we would have 6.022 times 10 to the 23rd molecules of HBr. But it asks us for atoms of just hydrogen. So in every 1 molecule of HBr, there is 1 atom of hydrogen. So if we have 3.00 moles of HBr, we first have to get to molecules. So we're 6.022 times 10 to the 23rd molecules goes at the top over the 1 mole of HBr. Then we need to get from molecules to atoms. So 1 molecule of HBr would go at the bottom so that it cancels out. And our 1 atom of hydrogen would go at the top. So the moles of HBr cancel out, molecules cancel out, and we're left with atoms of hydrogen. So when we multiply, we get 1.8 times 10 to the 24th atoms of hydrogen. And the last example for mole to particle conversions, how many moles of KMnO4 are in 3.022 times 10 to the 18th formula units? So we need to know how many formula units would be in 1 mole. 1 mole would have 6.022 times 10 to the 23rd. So we start with what we were given in the problem, 3.022 times 10 to the 18th formula units. We're trying to get to moles, so the moles goes on the top. 6.022 times 10 to the 23rd formula units would go at the bottom. And so when we multiply, we get 5.018 times 10 to the negative 6 moles. The last type of conversions, we have volume to moles conversions. So these are very important once we get to gas laws. So how many moles are in 8.23 liters of carbon dioxide at STP? In 1 mole carbon dioxide, we have 22.4 liters. So at STP, standard temperature and pressure, 1 mole of any gas is equal to 22.4 liters. So we have our 8.23 liters of carbon dioxide. We're trying to get to moles, so the 1 mole needs to be at the top. The 22.4 liters goes at the bottom. We have 0.367 moles of CO2. And how many liters will 4.5 moles of oxygen occupy at STP? So 1 mole of oxygen at STP is 22.4 liters. So we start with what we have in the first box. We have 4.5 moles. So the mole needs to go at the bottom, and our 22.4 liters goes at the top. And so it's 100.8. We need 3 significant figures. So 101 liters of O2.
Percent composition. What is percent composition? Percent composition is the ratio of mass that each element in a compound contributes to the total mass of the compound. It's a way of breaking down a compound to show the percentage of each element or ion by mass. What's it used for? Percent composition is most commonly used to determine the percent by mass of the individual elements within a compound. How do you find percent composition? You find the percent composition by using the following formula for each element in the compound. So percent composition is equal to the total mass of the element divided by the molar mass of the compound times 100. Let's try one together. Calculate the percent composition for each element in sugar. So the first step is to find the mass of sugar. So carbon is 12.011 grams, hydrogen is 1.008 grams, and oxygen is 15.999 grams. Remember to look at the periodic table to find the molar mass of whichever element you're looking for. Now we multiply by the subscripts. There are 12 carbons, 22 hydrogens, and 11 oxygens. So carbon is 144.132 grams, hydrogen is 22.022 grams, and oxygen is 175.589 grams. Then we add up all three of these to get the total mass of sugar, 342.297 grams. The last step is to divide each of the mass numbers, or the total mass of each element, by the mass of the entire compound. So we have 144.132 divided by 42, 342.297, 22.022 divided by 342.297, and oxygen divided by 342.297, and then multiply by 100. So we get, when we do this, we get 42.10% carbon, 6.43% hydrogen, and 51.41% oxygen. If we add those all together, we should get 100%. So what is the percent composition of each element in potassium iodide? So we need to know the mass of potassium and the mass of iodide. Potassium is 39.098 grams. Iodine is 126.904 grams. We have one of each, so we add them together. The total compound is 166.002 grams. So we're going to divide each one by the total mass and then multiply by 100. When you multiply, potassium is 23.55% and iodine is 76.45%. What is the percent composition of oxygen in baking soda? So the first thing we need to know is the total mass of baking soda. So sodium is 22.99 grams. Hydrogen is 1.008 grams. Carbon is 12.011 grams. And oxygen is 15.999 grams. But we have 3 oxygens, so times 3. So the total of oxygen is 47.997 grams. All of the other ones are times 1. So we add these together and get 84.006 grams. So oxygen divided by 84.006 times 100. So the percent composition of oxygen is 57.13%. Percent composition can also be used to determine the percent water within compounds like hydrates. Instead of a single element, compare the mass of the dry compounds against the mass of the compound with water. What are hydrates? Hydrates are compounds that contain water. The formulas for hydrates are written with an H2O. For example, CuSO4 dot 5H2O. This compound is called copper 2 sulfate pentahydrate. What is the percent mass in copper 2 sulfate pentahydrate? So we need to know the mass of the entire compound. So copper, sulfur, oxygen, and water. Copper is 63.546 grams, sulfur 32.06, and oxygen 15.999 times 4. Water is 18.015, but we have 5 of them. So water is 90.075 grams. We add all of that together, and our total mass for a compound is 201.68 grams. We divide the mass of just the water by the mass of the entire compound, and we get 44.66%. The next one, determine the percent by mass of the anhydrate in calcium dihydrate. So for this one, you're looking for the calcium chloride. So for the next one, determine the percent by mass of the anhydrate in calcium chloride dihydrate. For this one, you're just looking for the anhydrate, so the part without water, so the calcium chloride. Empirical formulas. Empirical formulas represent the simplest whole number ratio of the different elements in a given compound. This is a simplified version of the molecular formula. What are empirical formulas used for? This can be used to predict the formula of an unknown compound. Historically, much of what we know about compounds was developed using empirical formulas. How do you calculate empirical formulas? Step 1. Divide the subscripts of each element in the molecular formula by the greatest common divisor. Use the resulting numbers as the subscripts for your empirical formula. What about the empirical formulas of ionic compounds? Ionic compounds are already simplified. Their normal formulas are their empirical formulas. That means no math needed. How do you find the empirical formula if you know the mass of each element? Step 1. Find the number of moles by dividing each element by its molar mass. Step 2. Divide the moles of each element by the smallest number. Step 3. Check to see if any of the numbers are fractions. You must have whole numbers for the empirical formula. If you have a fraction, you have to multiply. If the mole ratio ends with 0.25, multiply everything by 4. If it ends with 0.5, multiply everything by 2. And if it ends in 0.333 or 0.67, multiply by 3. Step 4. The resulting numbers are the subscripts for the formula. Quick check. A compound containing 13.5 grams of calcium, 10.8 grams of oxygen, and 0.675 grams of hydrogen. What is the empirical formula? So we take the grams that we have, 13.5 grams of calcium, divide it by the molar mass of calcium, 40.078. We get a number of moles. We're going to do the same thing with oxygen. So 10.8 grams of oxygen divided by the molar mass. We get 0.67504. At this point, don't worry about significant figures. You need quite a few numbers to get the best answer. Then we do the same thing for hydrogen. Then we're dividing by the smallest number. So that would be 0.336845. So that comes out to 1. These both come out to very, very close to 2. So our empirical formula is Ca1O2H2. So we can rewrite this as calcium hydroxide. So the numbers that you get when you divide, those become your subscripts. What if the problem is in percentages? If you have a percentage, just assume that the mass percentages represent the mass. So 15% of oxygen would be 15 grams of oxygen. So determine the empirical formula for a compound that's 75% carbon and 25% hydrogen. So step 1, we say we have 75 grams of carbon. Then we're going to divide by the molar mass of carbon to get moles. Gives us 6.24427. We'll do the same thing for hydrogen. So we get 24.8 Now we're going to divide by the smallest, 6.244. So carbon equals 1. Hydrogen is 4.
So these become the subscripts
for our formula. So C1H4 is our empirical formula. Try the quick check on your own. What is the empirical formula for a compound which is 71.98% carbon, 6.71% hydrogen, and 21.3% oxygen? Pause the video and find your answer. Molecular formulas. What is a molecular formula? A molecular formula is the chemical formula of a molecule that includes exactly how many atoms of each element are present. How do you calculate molecular formulas? From empirical formulas and the molar mass of a substance. So calculate the molar mass of the empirical formula. Step 2, divide the molar mass of the given substance by the molar mass of the empirical formula. Step 3, multiply each subscript in the empirical formula by the number in step 2. So a compound contains 7.19% phosphorus and 92.81% bromine. What is the molecular formula if the molar mass is 431 grams per mole? So to find this, we have to have the empirical formula and the molar mass. We have the molar mass, but we are going to have to calculate the empirical formula. 7.19 grams of phosphorus. We're going to divide by the molar mass, which is 30.974. And we get 0.2321. We'll do the same thing with bromine. So 92.81 grams of bromine divided by the molar mass. And get 1.16. Divide by the smallest. So 0.2321. Phosphorus is 1. Bromine comes out to 4.997. So we can say that it's 5. Those are our subscripts for our empirical formula. So phosphorus and bromine is 5. Now we need to find the mass of our empirical formula. So phosphorus, 30.974, bromine, 79.904, and we have 5 of them. That equals 399.5, 2 grams plus the 30.947. So our weight is 431 grams. So we're going to divide the molar mass of the molecule, 431, by our calculated weight, 431. That gives us 1. Now we're going to multiply each of our subscripts by the number that we got from dividing. So our empirical formula was PBr5, and our molecular formula is also PBr5. Naphthalene is a compound containing carbon and hydrogen that is used in mothballs. The empirical formula is C5H4, and its molar mass is 128.16 grams per mole. What is the molecular formula? So our first step is to find the mass of our empirical formula. So carbon, 60.055 grams. Hydrogen is 4.032 grams. So the mass of our empirical formula is 64.087 grams. Now we divide our molar mass by the mass we calculated of our empirical formula, and we get 2. So we multiply each of the subscripts in our empirical formula by 2. So our molecular formula is C10H12. H, 8. Okay, try the last one by yourself and check your answer. Determine the molecular formula for a compound if it contains 50.05% sulfur and 49.95% oxygen by mass, and has a molar mass of 192 grams per mole.